All right, so I wanted to give the schedule for the next couple of weeks and what you can expect. There's been some questions about what it is that we're doing. We just took assignment number, or test number 1 and test number 2. Now these are practice tests. So the purpose of the practice tests is for you to make mistakes in an environment where it's okay to, and then you don't make them on the final, right? The whole point of this is to pass the final. The final is 50 times more important than any one of these tests. Essentially, the only thing that can impact your grade, one way or the other, is the final. And it's important that you know ahead of time, because it's so that it's not a surprise when the final comes out. Number 1 and number 2, let's see, these covered up to assignments. So this is assignment. This one covered up to assignment number 20, I think number 20, and this one is covering us up to assignment number 22. And then the number of questions. We started off with 7 questions. Every one of those 7 questions will be on the final. Number 2, this one here, has 9 questions, every one of which is on the final. All right, so this was all last week. And then this week we're taking tests 3 and 4. And then you need to be up to assignment 23 to be ready for number 3, and there's 12 questions. And then 26 to be ready for number 4, and there's 15 questions. Then the final has 20 questions, and that's on May the 12th through the 15th. It's important that you notice that this is a week before finals week. Okay, so finals week is down here. This is finals week, but we're taking the final the week before finals week. So we have 1 week less. This is this week. All right, so let's go ahead and do the solutions. Number 1, you need to divide this into 2 problems. So I'm going to put a slash right here, and then these numbers out in front are called coefficients. Coefficients. So I deal with the coefficients like they're a separate problem, and then I do the exponents. So the coefficients are 24 over 4. And let me do the exponents at this point. So that's x to the 5 on top minus 9 on bottom, y to the 6 on top minus 6 on bottom, z to the 1 on top minus 6 on bottom. And then if you would, could you circle this and then remind yourself, yes, I do want you to write the words don't forget, because otherwise you'll forget. All right, so now I can go ahead and simplify. So 24 divided by 4 is 6. That's the number out in front, so I can cross this out. And then it's x to the 5 minus 9 is negative 4. Y to the 6 minus 6 is 0, so I'm not going to write that at all. This would be correct, so this could have been okay here, but the 18 was wrong. But I'm just not going to write any y's at all. There's no y's. Z to the 1 minus 6 is negative 5. And so my solution is right here. All right, pause here if you're watching. I'm moving on. The coefficients, circle them. They are 8, 2, and 3. So I need 8 times 2 times 3. I want to say that I'm multiplying these things all together, and when I use the multiplication rule, which is that when I'm timesing, I add the exponents. I'm going to put a 1 here, 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 and here to remind myself that there's one of them there. So it's x to the 1 here plus 1 there, 1 plus 1. Y to the negative 4, negative 2, and positive 1. So there's negative 4 here, negative 2 y's here, and 1 y here. So that's negative 4, negative 2, and positive 1. And then z to the 3 plus 1, z to the 3 plus 1. So altogether that is 8 times 2 is 16, times 3 is 48. Oops, that's not a good 8. So I can cross out these two. 48, x to the second, y to the, this is negative 6. Negative 6 plus 1 is negative 5. Z to the 3 plus 1 is 4. So this looks like a none of the above to me. I like the negative 5. This part is right, but this part is wrong. So this is a none of the above. Number 3. This is a distribute problem. And that means they all get the 2. So 8 gets the 2, the x gets the 2, and the y gets the 2. So that's 8 times 8 is 64, x to the... just make sure that this is not 8 times 2, it's 8 squared. So 3 times 2 is 6, and negative 9 times 2 is negative 18. So the solution is, almost picked A, the solution is D. All right, and next question. This one is a mixture, okay? So this is a mix. First, I've got this thing up here, which is a times, 6a to the negative 10th times 12a. So my first step is to pretend that this denominator isn't even there, right? And the rule for doing that is to add the exponents. So first I'm going to add the top, add for the top, the numerator, and then actually the way I've been doing this works out just fine. So n for numerator, d for denominator, and then put them both together. N for numerator is 6a to the negative 10th times 12a, and then don't forget there's one here. So let's see, 6 times 12 is 72. A to the negative 10 plus 1 is negative 9. All right, so that's the numerator here is 72a to the negative 9, and then the denominator is just 18a to the negative 5th, and then I put the numerator and the denominator together. This is just like assignment 17, except that numerator, you're applying rule number 1, add the exponents, instead of rule number 3, distribute. And then you put them both together. All right, so 72 over 18, the best thing to do is to use a calculator, and Alright, so the 72 over 18 is no problem. I can just put it in a calculator. It makes 4. And then a to the negative 9 minus negative 5. And again, I can use the calculator, but that's a keep change, and I get negative 4. So that's 4 coming from the 72 over 18 and negative 4 coming from negative 9 minus negative 5. Use a calculator if you want to double check that that's equal to negative 4. And so my solution is C. All right, next problem, number 5. So I'm going to multiply by distributing 7 times x minus 6, and that's going to go here. And let's use a different color. 2x times x minus 2 is going to go here. So I need to prep those two things. So distribute the 7 to the x, 7x, and 7 times 6 is 42. And then I'm going to use the box method for this part. Put a monomial on the side and the binomial on the top. And I get 2x to the second power, and negative 2 times 2 is negative 4x's. So this is 2x squared minus 4x. And then to do the whole thing, I'm going to take this entire expression, negative 6x to the second plus 7x minus 6 plus 2x times x minus 2. And just like the hint said, I'm going to replace this. Whoops, let's use a better color. I'm going to replace this with what it's equal to after I distribute. So that's 7 times x and then minus 42. And then I'm going to replace the same thing here. 2x times x is, this is not a very good 42. Surprised nobody complained. 42. And then the 2x times x gives me 2x to the second power, and the 2x times negative 2 gives me negative 4x. That's from this term times this term. This times this gives me negative 4x. And then I'm adding that to 6x squared. So from bottom to the top, I've got my x squares here, I've got an x, and I've got a number. For the x squares, I've got negative 6 here, and positive 2 here. So positive 2 coming from there. And then from the x's, I've got 7 of them here, negative 4 of them here, and then the number negative 42. Okay, and that's all of the terms. So in the x squares, negative 6 here plus 2 here gives me negative 4x squared. 7 minus 4 is 3x and minus 42. So it is this one. So the answer is A. A rectangular courtyard. I'm going to draw the rectangular courtyard and then multiply the sides using the box method. Negative 3x minus 5, 2x, and minus 4. Those are the two binomials which I am supposed to multiply. Negative 6x squared, negative 10x, positive 12x and positive 20. Then I add the terms on the diagonal. 12 minus 10 is 2. So I'm looking for negative 6x squared plus 2x plus 20, and it is A. And then the next one I have to add all my like terms together. So I'm going to add negative 3x, 2x, negative 3x, and 2x. So in the x's, that's minus 3 plus 2 minus 3 plus 2, which gives me negative 6, and positive 4 gives me minus 2 in the x's, and those were the yellow highlighted terms. I'm adding them together here. So I've got 2x, so I can cross those two out, and let's see, negative 5, negative 4, negative 5, and negative 4 make negative 18. And so this is not negative 18, and so the answer is E, none of the above. And I got that by adding the x's separately from the numbers. Alright, if you're following along, then pause here. Next question is a factoring question. So the way that we've been doing these is with what I call a tic-tac. And I do like to write it down just so that I have something I can grade. I'm looking for two numbers that multiply to make 12 and add to make 7. And then 12, the factors of 12 are 1 times 12, 2 times 6, and 3 times 4. And which one of those adds up to 7? What are the two numbers that multiply to 12 and add to 7? No, 6 plus 2 is 8. 3 and 4. And so the two factors are x plus 3 times x plus 4. And the order does not matter because multiplication is commutative. Okay, so the two numbers that multiply to make 12 and add to make 7 are 4 and 3. And that's how you factor. Okay, for this one, I'm supposed to multiply to this, negative 5, and add to 4. So the ways to multiply to 5 are just 1 times 5 and negative 1 times negative 5. And so there is no obvious way of doing this. Okay, so these add to 6, not 4, and these add to negative 6. And so neither one of those work, and so the answer is none of the above.